Hey there! In this video we are going to look at what a system of equations is and what it means to find the solution to a system of equations. Now, to get started on this, we're going to look at this pair of equations they both have x and y in them. This one happens to be a quadratic, which you can tell because it has a squared here. This one is a linear equation because there's just x and y, no squared on either one of them or anything. What we're going to look at here is, are there any pairs of values that work for both of these equations? We're going to look at this a couple of different ways here. We are going to look at this numerically with tables of values to look at the numbers, and then we will look at a graph to see if we can get any insight into this. To try and create a table of values for each one, to make it a bit easier, we're going to rearrange each one and isolate y. I'm going to do this one first. If I'm isolating y there, the simplest thing to do is to move that x to that side. And what you end up with then is y all by itself on the left, and you have minus x plus 5. So that's the one I'm going to put on the table on this side here, negative x plus 5. To do the other one, the quadratic, you could do the same thing and move the x squared over, but since this is a minus y here, I prefer actually to move it to the other side, because then it becomes positive y, and leave the x squared where it is, and then move the 1 over to the left side, and you get minus 1. So that one is y equals x squared minus 1. If we're going to create the table of values for both of those, we're just going to use negative 3 to positive 3 here for each of them. And so for this first one, substituting those values in, basically it says negative x plus 5. Negative x means switch the sign of the x value, then add 5. So negative 3, switch the sign is positive 3, add 5 is 8. For each of those other values, you do the same thing. Positive 2 plus 5 is 7. 1 plus 5 is 6. 0 doesn't change sign. Plus 5 is 5. 1 becomes negative 1. Plus 5 is 4. You see a pattern there eventually. This one's 3. This one is 2. For the second one here, this says square the x value and then subtract 1. And if we do that, we actually don't even have to worry about whether the value is positive or negative, because when you square it, it becomes positive. Negative 3 squared is 9, minus 1 is 8. Negative 2 squared is 4, minus 1 is 3. Negative 1 squared, 1, minus 1 is 0. 0 squared minus 1 is minus 1. 1 squared minus 1 is 0. And you also see a pattern there. You're going to see these values repeat. All right, now the original question was, are there any pairs of values that work in both of the equations? And if you look at the table, there's actually one there that is the same over here. And there's also another pair of numbers down here that works for both of them. Those two pairs of numbers satisfy both the equations. You could try it in the original equation if you wanted to, and you'd see that it would work. We generated them with these rearranged equations, but it would work in the original ones as well. If we go up just to double check that, negative 3 squared, so if we're taking that first point, negative 3 squared is 9, minus 8 is 1. It works in that one. And negative 3 plus 8 is 5. It works in that one. That pair of numbers works in both those equations. If you pick any of the other pairs in the list, they'll work in one of the equations, but not both of them. This one is going to work in that equation, negative 2 plus 7. Negative 2 plus 7 is 5, but it doesn't work in this one. Negative 2 squared is 4, minus 7 is negative 3, not 1. Doesn't work in that one. All right? So from those tables, you can see there's those two pairs of values that work in both of them. We're going to look at them graphically here as well. I am going to graph each one on that grid. We'll graph the points that we have, and we'll see what it looks like. So we're going to do this one first. If you graph those points, we have negative 3, 8 right up there, negative 2, 7, 1, 6, 0, 5, 1, 4, 2, 3, 3, 2. If you draw a somewhat straight line through there, we can see what's happening. That's one of them. We'll graph the other one. We have negative 3, 8 is that point up there. We have negative 2, 3. We have negative 1, 0, 0, negative 1, 1, 0, 2, 3, 3, 8. That, if we draw and try to draw a nice smooth curve through that. It's not very smooth, but it will do. So that one is that parabola shape that you expect when you have a quadratic. And you can see that the two pairs of numbers that work in both equations are found at the intersection points of those two graphs. The red curve shows things that work in this equation. All the points on the curve satisfy that equation. The green curve over there is all the points that work in the first equation. The intersection points, those points are on both curves. They work in both equations. They're in both tables. All right? Those 2 points, those 2 pairs of values, are what you call the solution to this system of equations. This pair of equations is called a system. A system is a set of equations that have the same variables that are considered together. And the solution to that system is sets of numbers that work in all of those equations. So for this system of 2 equations with 2 variables, we have negative 3, 8, and we have 2, 3. Those 2 pairs of numbers are our solution. So in general, the term system of equations refers to a collection of 2 or more equations with the same set of variables. In this series of videos, we're going to limit this to 2 equations with 2 variables, and where the equations are limited to being linear or quadratic. And in general, the solution to a system of equations is one or more sets of values of the variables that will satisfy every equation in the system. So that's a bit of an intro to systems of equations. In subsequent videos, we are going to look at various ways of solving systems of equations, as well as using systems to find solutions in applied situations and real-world problems.